What is quantum physics? Welcome back to the channel, fellow seekers of knowledge. Today, we delve into the captivating realm of quantum physics, a subject that continues to baffle and intrigue scientists and enthusiasts alike. In this video, we embark on a journey to unravel the mysteries of quantum physics, exploring its underlying principles, mind-bending experiments, and remarkable applications. So, grab your virtual lab coats as we dive into the enchanting world of quantum physics. 1. Quantum foundations. Before we plunge into the intricacies of quantum physics, let's establish a solid foundation. Quantum physics, also known as quantum mechanics, is a branch of physics that focuses on the behavior of matter and energy at the smallest scales. It fundamentally challenges our intuition and the classical laws of physics that dominate the world around us. At its core, quantum physics deals with subatomic particles like electrons and photons, unveiling a realm where waves and particles beautifully intertwine. 2. Quantum superposition. One of the mind-boggling concepts in quantum physics is superposition. Imagine a coin spinning in the air. According to classical physics, it either lands on heads or tails. However, in the quantum world, that coin can exist in a fascinating state of superposition, where it simultaneously holds the possibility of being both heads and tails. This concept extends beyond coins and encompasses subatomic particles, representing an array of possibilities until measured or observed. 3. Entanglement and spooky action at a distance. Brace yourselves for the mysterious nature of quantum entanglement. When two particles become entangled, their fates become intertwined in a truly compelling way. Distances seem irrelevant as the properties of one particle become instantaneously correlated with those of its entangled partner, regardless of the physical distance separating them. Einstein called this phenomenon spooky action at a distance, as it defies our classical understanding of cause and effect. 4. Quantum uncertainty principle. Now, let's shed light on the renowned Heisenberg uncertainty principle. This fundamental principle states that we cannot simultaneously know both the precise position and momentum of a subatomic particle. The more we strive to measure one aspect accurately, the more uncertain the other aspect becomes. This principle shatters the notion of a deterministic universe, leaving room for probability and inherent uncertainty in the quantum realm. 5. Quantum applications. Quantum physics may seem abstract, but its applications are undeniably revolutionizing various fields. Quantum computing, for instance, harnesses the power of quantum properties to perform complex calculations at unprecedented speeds. This technology has the potential to revolutionize cryptography, drug discovery, and optimization problems. Moreover, quantum physics finds applications in cutting-edge technologies like quantum teleportation, quantum cryptography, and quantum sensors. 6. The role of quantum physics in our world. Quantum physics encapsulates the extraordinary wonders and complexities of our universe, stretching the limits of our imagination. It helps us comprehend the behavior of atoms, molecules, and the fundamental building blocks of our reality. From the microscopic world within our cells to the vast expanses of outer space, quantum physics plays an integral role in shaping our understanding of the cosmos. While quantum physics has provided a robust framework for understanding the microscopic world, it is important to note that many aspects of quantum mechanics are still not fully understood or reconciled with our understanding of general relativity and the larger-scale universe. The field continues to be an active area of research, with ongoing efforts to develop a unified theory of quantum gravity that can describe the behavior of particles on both small and large scales. In conclusion, quantum physics is a highly complex and intriguing branch of physics that deals with the peculiar behavior of matter and energy at the smallest scales. Its principles, including superposition, quantization, wave-particle duality, entanglement, and uncertainty, challenge our classical understanding of the universe. Quantum physics has revolutionized technology and paved the way for quantum computing. However, many mysteries and unanswered questions within the field leave room for ongoing research and exploration.